Hey friends, today we're talking about the line of best fit. If we look at the cookies in this table, they're asking us what year corresponds to 0 since 2000. So if we are looking at how many years since 2000 and there's 0 years, it's 2000. If it was 9, it would be 9 years. If we look at this data in a scatter plot, you would see that these are increasing over the time. So this would be a positive increase from left to right. A reasonable prediction for the cost of cookies in 2015, if we look here, would be on average between, would it be $3.25 or $4? If we look at this, in 2015, that means if we keep extending this on and on and on, right now at 9 it's $3.24. So would $3.25 be a good estimation? Probably not, because it's a positive association, it's increasing. So $4 would be much better. When data is collected, the points graphed usually do not form a straight line, but we can still find a line of best fit, okay? So that's what we're looking at. It's a line that's very close to most of the data points. Please make sure that you have that written down in your notebook. Line of best fit is a line that is very close to most of the data points. So the first step is to construct the scatter plot. If you look here, I've got a scatter plot already made for you from this graph. This is graphed from what we just did in the previous slide. If you look here, as you see, it's positive, but we can draw a line of best fit that's going to help us, and it should have most of the points close to the line. Same amount above and below the line. Please make sure you write that down. It should have the same amount above and below the line. So if we wanted to write a conjecture about the cost of cookies, we could say that if you extended the line, you could estimate the value for anything, like say example 2013 was 13, so the Y value for 13 is about $3.35. We can predict that in 2013 a pound of chocolate chip cookies would cost $3.35. So if your line ended say here, you could still extend the line and see what would happen maybe even in 2016 or 2018. So what we did here is we took our original, and these were the end point of our dots. So this part right here tells you what you can use to keep going on with an estimate. All right, so take a look at this scatter plot. Draw a line that best seems to represent the data. Use the line of best fit to make a conjecture about the points. Why don't you take a look at what I have here? The line of best fit, even though it looks kind of like they're clustered, would fall like this. Most of the points are not close to the line. If you look here, you have some of them above and some of them below. It goes through this first point, and that kind of helps us to make sure that our line extends out. If we wanted to use a line of best fit to make a conjecture about the points that will be scored in 2015, we extend our line out, and if you look here, it hits about here, which is a little bit less than 6,000, so 5,900. All right, why don't you try this one? Use the equation to make a conjecture about the number of cellular subscribers in 2015. Okay, if you look here, the year 2015 is 16 years after 99, so we've got to extend this line out way far. If you didn't want to use the line of best fit, you could use this equation. You could plug 16 in and figure out what your Y would be. So when X is 16, right, the years since 99, your Y would be, if you look here, 418 and 28 hundredths million cellular subscribers. So I want you to try this. The line of best fit shows the number of cellular service subscribers. Choose any 2 points on the line. They may or may not be data points. For example, if I chose 3, it would be 150, and if I chose 9, when you look at 9, it's falling at 275. I would, if I were you, try to find ones that you can gauge that way. Use these points to find the slope or the rate of change, and if you want to use mine, go ahead. Okay, so I'm going to show you what I did. We're taking functions, and we're taking what we did with slope and applying it to line of best fit. So remember, you have to first take and find m, your slope. Take your y's, remember doing this? y2 minus y1 over x2 minus x1. And when we do this, we get about 20.83 hundredths. That means that our slope is increasing every year by 20 and 83 hundredths. Okay, and if we look here, we can interpret that as an equation. We know that we're starting at what number? 85 is what they told us. So if we look here, we can say that the slope is 20 and 83 hundredths, and that our B, remember doing that? Our y-intercept is 85. Okay, tomorrow we're going to discuss this a little bit more. So that's all I have for you. Make sure that you have some notes, especially this formula again. So if we went back, you should have written in your notebook definitely what a line of best fit is, and the fact that all the data points need to be spread evenly on both lines, above and below it. You also need to make sure that you have an example with an equation, and then again how to find, as we recall, slope. All right, I'll see you next time.